Hello, I'm Jared Skeens, and welcome to the Zoom room. Today, I'd like to cover our Pure Maths 1 Quadratics unit, Part 2A, regarding completing the square. Now, you notice it's Part 2A. So yes, there's going to be a Part 2A and a Part 2B. I've split it into two sections. In Part 2A, we'll talk about training the mind, helping you to understand how this complete the square works and give you a visual aid so that you can grasp the concept. Then in part 2B, I will cover the skill of completing the square and what you'll need to do to be successful in the problem types. So it's important to first train your mind. I notice a lot of students struggle with completing the square. They either struggle with the skill or sometimes struggle with remembering the formula, and yet the formula is one of the easiest formulas in all of algebra, and they still forget it. And I'm convinced that the reason why students forget the complete the square formula is they don't really understand it. It's just this magic number shows up out of nowhere and they don't really understand what they're doing. So I'm going to try to help you in part 2A to understand what exactly completing the square is. And I'll also throw in some quick outline of the applications, like why do we want to complete the square anyway. Okay, so let's get started with a few observations, some important observations in this completing the square process. Okay, observation number one is completing the square is only done with quadratics, meaning you're dealing with an x squared term. When you see that square, that falls under the category of quadratics. So completing the square is only for quadratics. You don't do it with linear functions. You don't do it with cubic functions or any other polynomial. You only do it with quadratics. So notice it says complete the square, and we're dealing with expressions that have a square. Okay, that's important. Observation number two, even though the general formula for a quadratic is ax squared plus bx plus c, okay? Usually there's an ax squared plus bx plus c. We want to get rid of that a term. We want there to be a 1 as a coefficient. Now, in the skills part, in the part 2b, I'll show you how to get rid of that number. But for the concepts part, we'll just get rid of it from the beginning, okay? Because that's more of a skills than it is a concept issue, okay? So we're going to start with a lead coefficient of 1. The lead coefficient is your front coefficient, and we want it to be a 1 for this completing the square. So that's an important observation that I'll bring up again when we get to the skills part. If there's a number there, we're going to get rid of it. Okay, we're going to factor it out. Now, the third observation is that we are actually already starting with a square. Notice it says x squared. Okay, so we already have a little square here that's x by x. Now, we're going to look at two different examples. In the first example, we're going to look at starting with a square, and we're going to add something to it, but we still want our final to have a perfect square in it. So we're going to start with a square, we're going to end with a square. In the second example, we're going to start with a square, but instead of adding to it to make a bigger square, we're going to start with a square and we're going to subtract from it, but we still want to end up with a square. So in this case, we start with a small square, end up with a big one. In this case, we're going to make it big so that we can see it, and then we're going to subtract from it and make a smaller square, okay? In this process, not only will you be able to visualize what's going on, but you'll be able to better understand where in the world this formula comes from. And hopefully, if you understand it, you'll remember it. And if you remember it, then hopefully that will help you be more successful in the skills part where you actually have to do it. And later, like I said, I'll give you a brief outline of the applications so that you'll also see how many times you're going to have to be able to do this throughout the Peer 1 math book. So it's an important skill for you to get down. It's one that students struggle with. You've actually been introduced to this back in the IGCSE level, but my guess is most of you have forgotten it or you never really did get the skill down. So let's get into the concept part. Let's train our thinking so that we understand what is going on and how we get this formula. Okay, so it's with quadratics. We have a 1 as our lead coefficient, and we are already starting with a square. So in this one, because we're adding to it, we're going to start with a small square. And our small square, of course, is x by x, okay? Now, we want to add to this square. See, we're adding. We want to add to it, but we need to keep our square a square. In other words, if you only add to one side, you're making it a rectangle. We need to make sure that we add to both sides so that we maintain our square shape, okay? So actually the first thing that I should mention is this 2 does not work. You say, what does it mean that the 2 does not work? Well, normally when you're working with a quadratic, you try to factor it, okay? Well, this 2 does not factor to give us a 6, okay? So the number doesn't work. So down here, I'm going to write it again, x squared plus 6x. We're going to keep that part, but the 2 doesn't work. It doesn't factor to give us the 6. So we're going to actually move the 2 over, and what we're looking for is this formula provides us with the magic number. The number that we can put in here to make this factor into a perfect square. That's our goal. Now this is the algebraic part, okay? What I want to show you is the mental part. But you kind of need to know where the mental part is going in this. I'll explain the skill part in the part 2b, okay? Now, we started with a square. You see x squared, we have a square. We're adding to it. We're adding 6x. But like I said, if we add 6x all to this side, we end up with a rectangle. We need to add it to both sides equally so that the sides remain equal. Well, to do that, if we have 2 sides that we need to add it to, then we need to divide it by 2. Notice the 6 is our b term, the second term in the a, b, c. It's the b coefficient. So 6, we need to divide it equally along the 2 sides. So we get b divided by 2. And when we take 6 divided by 2, we get 3. So we're going to add 3 units to each side, okay? And we do 3 on that side. We need to also do 3 on this side so that we have maintained our square shape. Now, notice that if we were to, this is units of 1 in length. We've added 1, 1, 1, so 3 on this side, and we add 1, 1, 1, 3 on this side. And notice if we were to extend these along the length of the square, that this length on this square here is x, okay? And if we extend this along the side of the square here and extend this one and bring this down here, that this is also x, okay? So as we're starting to add up our area, you can see that the original square that we started with, x times x, well, that's our x squared. That's our first term that we have. Now we just added 6 more x's. Notice 1 times x, 1 times x. We're talking about area now. 1 times x, x, so that's 3x. And then along this side, 1 times x, 1 times x, and 1 times x. That's another 3x. So we've added 1, 2, 3, 4, 5, 6 x's, okay? Well, notice the square is not complete. It's not completed yet. We are missing this section right here, okay? So how do we find out how much area is in this section? Because we need to complete the square, we need to add a number to make this square complete. Well, if we continue our lines through, we'll notice something interesting here, and that is we now have these little squares that are 1 unit wide and also 1 unit this way. 1 unit this way, 1 unit. That means each of these are 1 unit area squares. 1 times 1 is 1, 1 times 1 is 1, and 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 1. And guess what we have? We have 9 squares that we need. Notice this is dotted line. We haven't added it in yet. We've added in the original x squared. We've added in our 6x part. So I guess I could make this solid here. We've added that in, 3x there, 3x here. But this we haven't added in yet. So remember, the 2 did not work. We moved it to the side. We're going to ignore it. We want to generate another number that does work. Well, we just saw that we had to take the 6 and divide it by 2 so that our sides are going the same amount in both directions. That was the b divided by 2. Now to come up with this magic number that we need to complete the square, we see that these 3 multiply these 3 give us 9. And when you multiply the same number by itself, it's the same thing as squaring it. So we started with 6. We had to divide it by 2 so that we're adding the same amount in both directions equally. And then we square that value and it gives us this missing area that we need. And so we now have the magic number that we need, and that is we need to add 9 to this expression. Now, this number was not originally up here. The x squared was there, the 6x was there, the 9 was not. So we just introduced a new value to our expression. In order to keep our expression equal, we have to equalize this 9, meaning if we add 9, we also have to subtract 9. Notice 9 minus 9 goes away, and we have our original equation. You're like, why do you want to add 9 and subtract 9? We're doing it to different places. We're adding 9 to this group over here, but we're subtracting 9 to this group over here, and the total expression is still the same value. It's still x squared plus 6x plus 2 because the 9s cancel. Think of it this way. When you're making, say, a cake, most cake instructions have you separate out dry ingredients from the wet ingredients. So you put like milk, melted butter, stuff like that in one bowl. And then in the other bowl, you put your flour, sugar, salt, things like that. And then after you've mixed the dry ingredients separate from the wet ingredients, then you mix them together and it becomes one cake. But you separate the dry from the wet for whatever reason. I don't know, I'm not a cook, but it all goes into the one cake, but you've separated the ingredients for a specific reason. Same here, we've separated these first three terms, the ones that we want to be our square, from these last two terms that we're really not worried about. But our entire expression, still same value, okay? Now that we've completed our square, well, let's see how it looks. When we go to factor this, well, the factors of 9 are, let's see here, 1 and 9, 3 and 3. They have to add up to 6. Remember, in part 1, we looked at factoring. Guess what? Here's a chance for you to practice your factoring. So factors of 9, 1 and 9, 3 and 3, they have to add up to 6. That's obviously the 3 and 3. So that means we get an x plus 3 times x plus 3. What do you know? They're exactly the same, because when they're the same factors, it means that you can write it as a square. We've completed the square. And then this section over here that we're not worried about, 2 minus 9 is a negative 7. So we started with a square, and now we've ended up with a bigger square. Now let's see if it makes sense with our picture. Well, here we have a side here, and what is the length of our side? X plus 1 plus 2 plus 3. This is x plus 3. And what's the length of this side? Well, x plus 1 plus 2 plus 3, that's also x plus 3. And we ended up with x plus 3 square. And then, like we said, the 2 didn't work, got included with the negative 9, and that got moved off to the side. We're not worried about that. What we want, start with a square, end with a square. Now, don't worry about the y right now. This is how it works so that you can understand and hopefully remember this very simple formula that a lot of students over and over again, okay, complete the square. I forgot the formula. If you're forgetting the formula, it probably means you didn't understand the concept. If you understand the concept and you have to complete the square, you go, oh yeah, a square, and we had to increase both sides equally. That means we have to divide by 2, and then we had to find the missing part. It was just multiplying the two, these numbers together, which means you're squaring it. And so hopefully you can remember this simple formula, okay? Now, remembering is part of it. Of course, the skill, the doing it will be the other part. Now, hopefully this makes sense for you. We started with a little square. We ended up with a bigger square. We now have our complete the square done, and then it's ready for application, which I'll discuss at the end of this. Now let's look at an example of subtracting from our original square. So we're starting with the square. Notice it's still a quadratic. We still we got rid of that a value. We're just assuming it's already gone. And then we are starting with our x squared term, but now we're going to subtract from it. So instead of starting with a little square and ending up with a big one, now we're going to start with a big square. That is x by x. So here's our original x squared term, and we're going to subtract from it. Now, same thing happens here as what happened here. This 2, the 2 doesn't work. In other words, you can't factor the 2 to get this 6. So we're going to push it aside just like we did here. So here we have, I kind of have this little over here. We'll just move it over here, x squared. Now we're going to subtract 6x, and the minus 2, we're going to move over here. So again, what we're looking for this magic number that does work, and we need to remember to equalize it, okay? Because we want to maintain the value of our expression. So if we introduce a number, we got to equalize it. So here's our big x squared. Now we're going to deduct 6x. Well, obviously, if I take 6x or any value away from one side, I'm going to end up with a rectangle again. So we want to maintain the square shape. So we want to subtract equally from both sides so that as our length decreases, it decreases equally and makes our square shrink and still be a square. Okay, so again, since we have to do it equally on two sides, we have to take our b term again, the b number, and we have to divide it by 2 because we need to do it equally on two sides. So now we're going to take away 3 units, 1, 2, and 3. And I have to take away 3 units from this side. Okay, so now we get this square in here, and we've taken away this much. Now, what I'm going to do is we need to figure out how to get rid of all of this area. We're taking our bigger square, we want to reduce to a smaller square. So to do that, you actually have several choices here. There's actually 3 different ways you can do it. I'm just going to show you one so that you get the idea of the concept. So one thing that you can do is you can take these lines all the way down the full length of the square here. Okay? That means we've taken a width of 1, 1, and 1, and a width of 1, 1, and 1. And on this length here, remember this outer length is an x. Our big box is x. So now we've subtracted a 1x, another 1x, and another 1x. So what we've done is we've taken our x squared and we've subtracted 3x. Okay? So we don't have the full 6x yet. We've done that part. And it's filled out all of this. We've reduced it. Now we got to figure out this part here because we're trying to reduce it to this square. So we've already taken that out. Now if we look at this, this doesn't go all the way through. It doesn't go all the way through because we've already taken that out. So this, if we extend these lines, they only have to go to here. They don't have to go the full length of the square. They go the length of this square here. Well, what now is the length of this square? We had x and we've subtracted 3. So if we had x and we've subtracted 3, that means we have x minus 3. Same thing here. We had x for the full length. We've taken away 3. So now this side in here is also x minus 3. Well, let's see how this works. So if this is 1, and now this side is, we see x minus 3. So we have one of those, 1 x minus 3, and another x minus 3, and another x minus 3. Then that means we're subtracting 3x minus 3. Okay? So when we do this, we see that this distributes and gives us a negative 3x plus 9. And when we combine this together, we get x squared minus 6x plus 9. Okay, now remember, let's go back to our magic number thing. The 6 divided by 2 gave us our 3. Okay, so 6 divided by 2 gave us the 3. Then we squared it. Well, what happens when we square the 3 times 3? What it's doing is it's giving you these 9 little pieces here. 1, 1, 1, 1, 1, 1, 1, 1, whoops. 1, 1. And so we have added 9 to this here. Now, this 9 was, this plus 9 is already included in this section here. So when we took out the minus 3x, that plus 9 is already included in that. So that actually is the magic number. When you follow this minus 2 out here, all of this is for the square. Remember, the 2 doesn't matter. So we still have our minus 2, and we added the 9. The 9 came from right here. Now, the way I explained it is easier for you to see how all the area is subtracted out. Where the 9 comes from is a little bit trickier. I'd have to go into the other ways of explaining it so that you can see the plus 9. All you need to know is that plus 9 comes from right there. It's actually included in the way that we calculated it, so we have all that area, and it shows up as plus 9. That's what's important. It's the same number as over here. The b divided by 2 squared is the plus 9, meaning you have to equalize it. You have to take away 9, so now you get negative 2 minus 9 gives you a total of minus 11. We're not going to simplify those because we want to factor this. Remember, this part is our separate part. So when we factor this, again, the factors of 9 are still 1 and 9, 3 and 3. That still add up to 6, but it's a negative 3 plus a negative 3. So we get x minus 3 squared and then minus 11. The outside number changes, but that's okay. We don't care about that number. What we care about is maintaining that perfect square. So we started with a big square, we deducted from it, and we ended up with a smaller square. On this one, we started with a smaller square, we added to it, and ended up with a bigger square. So the magic number that allowed it to factor perfectly was the plus 9. Notice again here, we have the x squared, that's the original. We have the minus 6x, that's original. The negative 2 we pushed away. This plus 9 is that magic number, and we had to equalize it, which joins with the negative 2 to make negative 11. And here we have our perfect square. Here we have our perfect square. So I hope that helps you better understand what exactly is going on in this concept of completing or maintaining that square shape, and especially with regard to the magic number part or our formula that gives us that magic number. And again, you have to equalize it to maintain the value of your expression. It allows you to end up with this perfect square in your expression. So I will set this up to give you a quick, just a rundown of the application so that you know why are we doing this. I mean, yeah, this looks okay, it's kind of cool. You start with a square, you play with the algebra, you still end up with a square, but it just looks like a game to you or a puzzle. Why are we doing it? Okay, so I'll set up to share with you just briefly the applications and the ways that you will need to apply it in the future in the P1 math book so that you have an idea of what's ahead. Okay, here I'll give you an idea of what you're going to do with this complete the square form. Well, I've listed for you 6 things that I can think of off the top of my head that you will face coming up in this Pure 1 math book. There might be more. These are 6 things that I can think of right away, applications of what you're going to do after you get the complete the square form. What do you do with it? Well, I'm not going to show you all of it because, well, you haven't learned it all yet. Now, these first 2 I put in blue because you were already introduced to this in IGCSE. So I'll briefly, quickly demonstrate. If you have a solving, let's say you had a x minus 3 squared minus 16 equals 0. Well, you can use the complete the square for solving. Now, I find it interesting that some students, when they look at this, they multiply this out. They expand it out and make it into a big polynomial again. You don't have to do that. It's already a square, and if you notice, 16 is also a square. So you just move that to the other side. You get your 16. Then when you square root, don't forget square roots have plus or minus. A lot of people forget that. So you get x minus 3 equals plus or minus 4. Then you add the 3 to the other side. So you get 3 plus or minus 4. And then your answers are 3 plus 4, which is 7, or 3 minus 4, which is a negative 1. So it can be used in solving. That is generally the first thing you're taught as an application of completing the square. Although I have to be honest, unless your form is already in the complete the square form, I generally wouldn't use it for solving. In other words, I'm not going to go through the complete the square process just to get it into that form so I can solve. We would use the quadratic formula or another method to solve it, generally not completing the square unless, like I said, it's already in this form, meaning you didn't have to do the complete the square part, someone else did it for you. So if we already are starting in this form, yeah, it can be used for solving. It's not really its main purpose, but that's what they start you out with in the IGCSE material. So the second thing, and probably the more practical one as far as your IGCSE went, and that is for vertex of a parabola. Remember, your parabola is a diagram shaped like this, and that your parabola is symmetric, has a symmetry, and right at the lowest point, or the highest point if it's facing downward, that is called your vertex of the parabola. Well, one of the things that your complete the square form does is it puts it into what I use as the H and K. The letters can change, depend on curriculum or the teacher. I use H and K. This is your horizontal and vertical translation of the graph. It helps you to translate, meaning shift your graph from the origin. So your vertex is shifted H and K. The opposite of this, the same as that. Hopefully you remember that also from the IGCSE material, but that's an important, so it's used in an interpretive graph interpretation manner, okay, as the application. But you don't know where the vertex is at if it's in the form of ax squared plus bx plus c. You can't see it by looking at that form. There is a way to solve for it, but again, you go back to the quadratic formula to use part of that to figure out where your vertex is. So if you haven't learned the quadratic formula yet, you're completing the square can provide for you just at a glance right away. You can tell where the vertex is at. Now, those are the things you should have already been exposed to in the IGCSE material. Now, as we move forward into the Pure 1 math material, you're going to have to do the completing the square as a skill. That means you're just doing it, not applying it, in the quadratics unit. After the quadratics unit, we get into the functions unit. And you had a little bit of functions previously as well. So in the functions unit, you're going to learn a little bit more about domain and range that you didn't really learn as much previously in IGCSE material. They usually provide the domain and range for you. They don't make you find it for yourself, which you're going to have to learn how to do. So for domain and range, well, domain is your x-axis value. So the h part will help you in determining domain. Not so much, I mean, actually your domain of the graph goes on forever in both directions. It's to infinity and negative infinity. But when you go to make an inverse function, you're going to want to limit the domain of the graph. You don't need to understand it now. You're going to use that h value, which comes from your complete the square. You're also going to need to identify the range, which goes from here up. That one comes from this value. So the range straight up relates to the k. The domain is more when you're going to take your original function and make an inverse function. You got to limit the domain. That comes from the h value. Both of those, again, come from the completing the square. Helps you do some interpretation for functions, which will be the next unit in Pure Maths 1. The unit after that, also in the inverse function, you're going to get into finding the inverse of our quadratic. If you remember from IGCSE material, you already learned how to find the inverse function. 2 rules, switch x and y, solve for y. Again, we'll refresh that again when we get to functions unit. But if you switch x and y, you're going to have 2 y's with different powers. A y to the first power and a y to the second power, and you're going to get stuck. You're not going to be able to isolate the y value. So what we do, we complete the square. Now when you switch the x and y, you only end up with 1 y value, and you can then solve for y and get the inverse function. So this completing the square is very important for finding the inverse function of a quadratic. You didn't run into that problem in IGCSE because they didn't really give you quadratics to find the inverse function of. They give you linear or some other type that was easier to do. Okay, so you're going to have to expand your ability in that inverse function area, specifically with quadratics, and the completing the square is going to get you there. So then after that, we get into coordinate geometry. And in coordinate geometry, we talk about lines, but we also talk about circles. Well, guess what? The circle formula looks like this. Where the center is at h and k, and the r is the radius of your circle. And now you have 2 perfect squares, meaning you're going to have to complete the square twice. One with the x variables, once with the y variables, to get your perfect squares so that you can have your equation of your circle. So you get to do it twice in one problem for coordinate geometry with circles. Then lastly, I'm not going to really show you this. Increasing and decreasing functions is later on in the unit, towards the end of the, or not the unit of the book, when we get to derivatives. And in order to determine whether something is increasing or decreasing, we use the perfect square. Why? Because a square always ends up being positive. So if the sign in front of our square is positive, in front of our square part, then that means it will be an increasing function, because whatever you have in here squared is obviously a positive number. times a positive, still positive, it's increasing. If you have a negative in front, whatever in here squared will be positive times a negative becomes negative, so you will have a decreasing function. So I don't really want to get into a lot of that now because we haven't learned enough material to really make sense of it. But here you've got IGCSE material. You have the skill in quadratics. You have 2 applications in functions unit, 1 application in coordinate geometry unit, application in the derivative unit. And so here you see at least 6 plus the skill itself, 7 different times you might have to complete the square. So please, when you get to the part 2B, really pay attention and learn the skill. But I hope that at least in this part A, you get a mental grasp of what's going on, and you see that that magic formula b over 2 squared, hopefully you understand that better so that you don't forget it. And now you also see that you're going to run into this many times in the future, so make sure you learn the skill carefully. If you didn't get it down in IGCSE, you need to get it down now so that you can be successful in all these different units as you learn other things that go along with the application for this. So I hope it helps. Good luck on this, and I'll see you again for part 2B when we discuss the skills part, how to do it.